classification. This project is a part of summer internship program of Leadingindia.ai in the guidance of Benet University. Our project was guided by Mrs. Anjali Yadav. The team behind this project is...
Hello friends, this is Archana Bhatia. I am pursuing my BE in Computer Science from VES Institute of Technology, Maharashtra.
This is Anusha, pursuing Information Technology BTech from VR Siddhartha Engineering College, Andhra Pradesh.
Hello guys, this is Sindhu. I am pursuing CSC from SRKR Engineering College, Andhra Pradesh.
Hi guys, this is Akmal Hussain from Techno India Engineering Institute of Technology, Udaipur. Insect disease and weeds are some of the biological factors which are responsible for the miserable condition of the farmers today. Many times the impacts of weed is not as clearly visible as the of insect and disease. Managing and controlling weed growth is therefore the most important. In this project, we collected sample images of soybean farms to classify weeds among soybean crops. So to attain this, we have downloaded sample dataset named Weed Detection in Soybean Crops from Kaggle.
Talking further about the dataset, it is prepared by a set of 400 UAV captured weed containing images. After performing image segmentation, it has resulted in around 15,000 image segments which are arranged in 4 different classes. The classes are soil, soybean, grass and broadleaves. Broadleaves are considered as weeds in case of soybean. Thus, the size of our dataset is around 2.4 GB. Now let's talk about the models we have used. We built 2 models. First is convolution 2D model, which is built from scratch, and second is the classic DGG16 model. After performing the training and testing on our models, the model was very successfully able to identify which are weed plants and which are not. It was able to classify the plants among the...
After downloading the dataset from Kaggle, our main idea is to split 80% of the data into trained data and 20% of the data into test data. For this, I have created 2 folders called trained data and test data with subfolders broadleaf, grass, soil and soybean, which are the 4 major classes we need to predict. So for splitting the data into 80% of the data as training and 20% of the data as testing, here is the block of code for splitting the data. Here we can see the number of images falling for trained data and test data after splitting. So coming to the convolution model, I have used 1 input layer, 3 convolution layers and an output layer. Here relu is the activation function for the convolution layers and softmax is the activation function for the output layer. Here is the model summary defining the output shape of each layer. I have used Adam as an optimizer to compile the model and ran the model with 10 epochs. At the 10th epoch, I have got 99% of the accuracy for training and 94% of the accuracy for the testing thing. So let us have a look of the graph for accuracy and loss of both training and validation thing. Here is the graphs for training and validation accuracy, and this is the graph for training and validation loss.
After building the Conv2D model, we began building BG16 model for comparative analysis. Here we used 1 input layer and 4 hidden layers and leaky relu as an advanced activation function. In order to attain good accuracy and less parameters, we used 2 dropout layers. And in order to classify 4 neural filters, we used softmax as an activation function. And to compile the model, we used Adam as an optimizer with learning rate 0.01 and run the model with 10 epochs. So here are the accuracies we got after running the model. And here we go, we plot the graph between accuracy and loss functions. Here are the graphs we plot for our model. So to test the model, we created a directory named testing outputs and uploaded the images which are to be classified in it. So here we go. Here are the results after classifying the images by the model. So our model is to identify the weeds in the soybean cultivational field, so the machinery can easily pluck them, the weeds identified.